The topic of this session is how to scale enterprise-wide Kubernetes adoption. Let me go to the next slide. Again, thank you all for being here, and a big thank you to the Platform Engineering Meetups group for hosting this event and inviting me over. I really hope you all have a wonderful session. So brief about me. Currently, I'm working as an Assistant Director, Cloud Practice at EY, GTS, and Nestia. Before that, I used to lead a team of around 21 cloud engineers/architects as CCOE, Cloud Center of Excellence. I have around 11 years of experience now, and I have been working on public cloud technology since 2017, initially on AWS, then on Azure. Okay, what is the agenda of today's discussion? Initially, what I will first start with is basically discuss the standard Kubernetes adoption process in any enterprise. Then what are some of the issues or challenges in scaling this adoption across an enterprise? 1 or 2 clusters is okay. What happens when you try to do it at scale across your entire company? Discuss some of the potential or feasible solutions to handle those issues or challenges, and discuss how a central excellence team, for example, like a Kubernetes Center of Excellence or a central container team within your internal platform, teams can really help you basically solving some of these issues that we see crop up. Some expectation management at the starting of the session. This is not like a session on how to get started on Kubernetes deployment, YAML services. There are hundreds and tons of resources today, to be very fair, are available. There are very good courses. The expectation is that you already know Kubernetes, what Kubernetes is. Rather, you are here, for example, because you have reached the threshold where, for example, things are starting to break now across stuff. You are not able to understand how your teams can be structured in a way so that you can actually cross this threshold and then reach a massive scale of Kubernetes adoption. This is more for people who are running a lot of clusters in production across teams. Some are using different kind of flavors of Kubernetes. So many things are here. So basically, people who want to scale their Kubernetes usage across an enterprise environment. Okay, perfect. So with that context, let's get started. Everybody knows that, right? I mean, most enterprises are today interested in adopting Kubernetes. It has kind of become the de facto computer hosting model, so to speak. So, and on cloud and even on premise, primarily on cloud, everybody, for example, people who earlier used to initially think about VMs, even web apps are now thinking about Kubernetes. I'm not saying always it is the best way to go or the best option, but that is what it is today in the market. And in your Kubernetes adoption report that CNCF publishes, if you see, it shows around 95 or 92 or 95% of developers today use Kubernetes in some way or the other, which is huge. Basically, it has kind of stormed the scene. But what does managing Kubernetes at scale look like, and why do I say that it's extremely difficult? What are some of the problems? First, before we do this, how do we define an enterprise? So when I'm talking about enterprise, I'm talking about really big companies like Ford, General Electric, Walmart, United Health Group, some of other big companies, okay, which has multiple departments, locations. There are hundreds of teams who are spread across the company, possibly globally distributed. For example, in most of these enterprises, you don't even know what is happening in the other team, even though you might even be reporting to the same boss, to be very fair. Everyone has clear responsibility hierarchies, but there are a lot of silos. So this is a very typical enterprise. This is not like your high-performing startup with, say, 100 very good engineers or coders. This is a typical enterprise that has been, for example, doing a lot of, maybe has a revenue of $4 to $5 billion, has maybe 1,000 plus employees. So this is what I'm referring to when I'm using the term enterprise. And what do I mean by at scale? So by at scale, I mean that you guys are trying to do a rapid digital transformation. Basically, for example, there are typically initiatives that you guys want to take as an enterprise where there are hundreds of teams, thousands of developers or engineers are being impacted by some of the decisions that you are taking. And the pace or the agility is very high, okay, high velocity basically. And this is what we are trying to say by at scale. So basically you are in an enterprise, which is a very big company, and whatever decisions you are taking at scale, and all of these decisions are most likely will impact hundreds of developers or even more and hundreds of teams. So how are things today operating across many of these medium to big enterprises, many of them? And this is something we have done an assessment, and based on that, this is my personal feeling and something I have been in the industry for a long time, working with Kubernetes in some of its early days. And this is what I still see in many organizations while doing consulting work, is that so there is a developer somewhere who has got this idea, okay, and they start working on Kubernetes. Okay, And it's good, right? The moment you start doing Kubernetes, it has its own charm. So you like what you have, like that control that you have. And with this cloud-based Kubernetes platforms like AKS, EKS, the infrastructure part is also quite seamless. So for example, a developer team will deliver a successful project on Kubernetes, okay, on their own, basically. No, they don't have a lot of central guidance, best practices. They're just doing, learning as they are doing it, maybe doing a little bit Googling, reading a few early Kubernetes books, and then delivers a successful project. And then they kind of get onto the scene and start telling everybody that, okay, we have done this thing on Kubernetes, and everybody's like, okay, yeah, Kubernetes is the next big thing. How did you do? Okay, this is really good, very good. Now let me also get onboarded onto Kubernetes. So more and more teams will now try to get onboarded onto Kubernetes, because there is this thinking that, okay, if I'm on a VM, I need to go to Kubernetes in some way or the other. Okay, not always this thinking is correct, but there is this thinking. But the problem is, the more and more teams start getting onboarded onto Kubernetes, there is a lack of a central governance, right? Because there is no organic, the thing has not grown organically. Okay, so it's just because of my word of mouth, people are saying, okay, let's do it. Let's, because of the lack of anything else, let's just get onto Kubernetes. So every team is essentially doing their own thing. They're not following any standards, they're not following any best practices. Finally, something will fail. Obviously, Kubernetes is also very complicated, to be very fair. Running Kubernetes production is not a very easy feat. So when things start failing, many of these people don't have a reason why. They don't understand what is happening. When there are so many microservices, dependencies, something fails, so you don't understand. So as a while, a kind of a feedback goes back that no, Kubernetes is too hard. It's not worth the time. Okay, it's not worth the energy. So new teams will get put off. And this has happened many times. People have started moving their workloads from a traditional virtual machine to, for example, some sort of a container orchestration platform, and then again saying, no, everything, I have lost a lot of time, a lot of agility. I'm getting so many errors. I don't know where to look. This service doesn't work. That service is not exposed to an ingress controller. So as a result of this inorganic growth and lack of central governance, best practices, so your at-scale adoption initiative. So the fact that Kubernetes really could have been your driver for digital transformation, you are losing out on that. Okay, so this is what happens. And this is what I call the great Kubernetes divide. So this is a current state. If you see the current state, every team within the enterprise is kind of doing their own thing. Somebody is using Helm chart, somebody is using just something else, somebody is using GitOps, Argo. Everybody is kind of doing their own thing. Whereas, what do we want to be? We want as an enterprise to be somewhere where we can scale at standardize. We can scale our development, our deployment processes, so that any new team can get onboarded quickly and do the same thing in a similar fashion across the enterprise at scale. So all teams need to follow a set of standard guidelines, practices, and patterns. But this is not so easy. Anything is not easy at scale across an enterprise, and Kubernetes in itself being inherently difficult. When you try to do it at scale across an enterprise, it becomes much more difficult. So it's very hard to move across the divide. And as I really started with, Kubernetes really hard, right? So basically, for example, there's a quote from the Docker co-founder, Sebastian. He said about Kubernetes, the simplicity has not won. I love Kubernetes, but it is not for normal humans. So there are so many memes going around across. One time I tried to explain Kubernetes to someone, then we both did not understand it. So these are all of the standard memes, because to be very clear, Kubernetes is not that it gives you a lot of flexibility, and it has its nuances. Once you get on the hang of it, it's not very bad. But again, it's not that simple. So if Kubernetes in itself as a technology, as an offering, is not that simple, now when you add to it the complexity of managing it across hundreds of teams, thousands of clusters, it becomes a beast. Okay, and so what are some of these challenges that most of these enterprises are facing when they're trying to scale Kubernetes? So one of them is there is still today a lack of enterprise-grade Kubernetes management platform. So say, for example, if you say the ERP world, today there is a lot of standardization. You have SAP, you have Oracle, you have PeopleSoft somewhere. For any of the most of the other standards, say, for example, you look at an ESB or integration pipeline, you have MuleSoft. For workflow engines, you have Pega, ServiceNow. So there is a lot of standardization, a lot of enterprise-grade platforms that have stood the test of time. Okay. Whereas, for example, okay, so there is a so this is another poll that has, I think, Florian has started this poll. So it would be really good if you guys can take some time to maybe set the context and just answer this poll. Maybe in just take 1 or 2 minutes to answer this poll so that we can use some of this data going forward.
Yeah, cool. I just launched it. I hope it was the right slide, and I can see answers rolling in, and I think it already looks pretty stable. Or let's wait a few more seconds.
Okay.
Yeah, I think that works, and happy to share the results. I hope you can see it.
Yes, I can see it.
So close to 70% have Kubernetes in production running, almost 80% less than 10 Kubernetes clusters, but also a few 4% with 200 plus, 4%, 50 to 200, and 13% 10 to 50.
Exactly. No, but these are really good statistics. And basically, to be very fair, if for the project teams or the teams or the companies who have now less than 10 clusters, it really doesn't take a long time to reach that much. Say, for example, there many companies have that thing about, say, for example, if you want to deploy for an isolation, every single application needs to be deployed on the same Kubernetes cluster. So the moment you start doing this and you look at any single enterprise, even if they have, say, for example, 250 applications, out of them, even if I take, say, 50% of the application, like 125, and even if each of them has a single Kubernetes cluster, then also you have very easily 100 clusters, right? Similarly, and there are many other nuances where, for example, you need another cluster for dev, QA prod, maybe another cluster for your performance testing. So very easily one application can have 3 clusters. So with 100 applications, you have 300 clusters. So it's very easy to go into these problems that I'm talking about, which is like challenges of scaling Kubernetes. So the first main problem is that even though there are now some new tools, there are, again, not the level of the maturity that we have for the other disciplines in IT, but yeah, there are like VMware Tanzu, then there are some other tools, OpenShift, which are trying to do this. But again, still, to be very fair, there is this lack of that kind of like very good enterprise level tool that can kind of do everything with a lot of stability. Second challenge is there is a lack of available resources or engineers who know Kubernetes well. There's a real resource gap. There is some people who might have just studied a little bit of Kubernetes and they're starting doing the work, but people who know how their things actually work, what is failing, is really less number. Kubernetes is again mostly used for loosely coupled, distributed, microservice-based stateless applications. These are by default very hard to design. So inherently, even without Kubernetes, they have a lot of issues. Okay, even if you had, for example, deployed the entire thing on a single virtual machine, big virtual machine, then also you would have faced a lot of issues. Right now, you are coupling that with, in a sense, this essence of Kubernetes, where you have to maintain all of this, lot of problem network policies, many things are there in Kubernetes, to be very fair. So the fact that Kubernetes itself is difficult, and along with that, the challenges at scale makes it more difficult. And it's still relatively new. If you look at some of the other IT technologies that we have today, Kubernetes is still relatively new and still undergoing significant changes. So very frankly, some of the best practices, some of the standards, some of the patterns are continuously evolving. Okay, so every now and then a new version of AKS will be, Azure Kubernetes service will be released, and you will be asked, for example, to upgrade. Otherwise, you will lose, for example, the support from Microsoft. Right. Whereas, for example, with servers, they were still supporting 2012 till a few days back. That is the kind of thing I'm talking about. So it's a developing thing, basically. It's a very fast changing landscape. That is why all of these challenges are basically getting amplified. Okay. Next slide. But again, fortunately, in enterprise IT, we are engineers. Most of these problems have solutions. And some of the solutions are some of the aspects that I have done and learned from some of the implementations I have worked with. So these are some of the potential solutions at a high level. And again, these solutions, 90% of the solution you can even apply for fixing any problem which is recurring in an enterprise at scale. Okay, for example, standardization. Okay, self-service cataloging, consistent support model, automation, documentation, creating a center of excellence, managing cross-cutting concerns. These are all solutions which are obviously applicable for this use case that I'm describing here, but also they're applicable for many of those challenges that a standard enterprise system sees. So let's deep dive into some of the solutions, because that is the main. So the problems I think we can agree on that there is a real problem today. For Kubernetes in itself, even if you manage just 1 or 2 clusters, it becomes very difficult. So now think about managing, say, 600, 700, 800 clusters. It's not a very easy thing to do, but somebody has to do it at an enterprise level, right? Otherwise, the entire initiative will fail. So the first and foremost thing is standardization. I think everybody agrees that for any initiative to succeed at scale, you need a standardization. Everybody will come and say, no, my use case is a little bit different than your use case. But at the end of the day, the underlying offering needs to be standardized. So every single cluster that has been provisioned in your enterprise, every single cluster needs to look the same as the other cluster, meaning from an essence perspective. Obviously, the number of node pools and all of those things might change. Somebody will use CNI plugin, somebody will use maybe Kubernetes. So those things might change, but it should come from the same template or script or pipeline. There should not be like, for example, I am creating a Kubernetes cluster via the portal. You are creating it using ARM. Somebody else is creating it using Terraform. No, there should be no deviation as to the basic principles or the philosophy or the attributes between 2 Kubernetes clusters that has been set up in the same enterprise. This is the overlying architecture. And no team should write their custom script to set up or operate a new cluster from scratch. So everything needs to be standardized. And some of these nuances or some of these principles that I'm explaining here, these best practices, again, can be applied to something else also. So any other offering also you can. So standardization is the key to succeeding in any initiative that has to scale across an enterprise. So we need a standard Kubernetes cluster. But how do we get it? That is the next question, right? Say, for example, I'm telling to every engineer in my company, all say 10,000 engineers, that you need to deploy all Kubernetes clusters in a similar way. But the next question is, okay, how will I deploy, right? How will I get? So that is why you need your Kubernetes cluster creation, or its management, or basic operations as part of the standard IT service catalog. So there needs to be a service catalog or a marketplace or something within your enterprise that you today use, for example, to create your email account. Okay, so some of those same IT service offerings that you have today listed in your ServiceNow catalog, maybe you need to have an offering there to create a cluster, to delete a cluster, to change a few items in that cluster. At least at a high level, that is what you need to do, at least for the setup of the cluster. So the cluster creation is management should be as self-service as possible. Where, for example, I as a team member or somebody who needs a cluster, I will just log into that portal, give my charge code or something, select the parameters, and then deploy the Kubernetes cluster. Obviously, the parameters will vary from, I might need Linux node pool, you might need a Windows node pool. All of those differences, nuances should be there, and my self-service offering should be customizable enough to be accommodating enough of those nuances. Because the moment I say, no, my self-service offering does not support this, then that team will create its own cluster. So I need to be as accommodating as possible of all of the nuances which are generic enough for me to accommodate. Say, for example, this is a self-service catalog, just a mock-up I'm saying, where, for example, I am a DevOps engineer, I am coming here, I am clicking on provisioning a standalone Kubernetes cluster. It will create a form, I will give some of my inputs. Okay, I need this cluster, this is my region, this is the vCPU, this is the storage, all of those things I will give. And then, for example, I will put a button, some automation will run somewhere in the backend, and it will provision me a cluster. It will maybe give me some kubeconfig file or some other service connection, something it should give me so that I can connect to that cluster. Once I connect to the cluster, then I will operate that cluster in my own way. There are also nuances in the operating of the cluster, but this is just the starting point. And this is as much as you can do this, it's better. It's not that everything will be at this level. Not all companies can operate at this level of maturity, but you can think of it as a target state for your environment. You want to reach this place, to be very fair. Now, what are the catalog of Kubernetes offerings? So again, like I said, that your offerings should be nuanced enough, should be diverse enough that it accommodates most of your business users, right? So say, for example, multiple customers might need different kind of Kubernetes service. Say, for example, there could be some people who need a dedicated cluster for their tenant. For example, I have my project as money, I have budget. So I want to run a dedicated AKS cluster or EKS cluster, GKE cluster. I don't want to share my cluster with other teams. I will have one cluster for prod, one for non-prod, and maybe one for performance testing. So I want 3 clusters. Whereas then there are some other applications, for example, who just needs a very small compute environment where they might be hosting a e-commerce or a web application or a WordPress blogging site, for example. So in that case, I really don't need a dedicated Kubernetes cluster, right? As long as I get a namespace within a very big cluster managed by somebody else, like a multi-tenant cluster, and that namespace is my tenant. So I will just log on to that namespace. I will have access just onto that namespace. I will deploy my application or workload onto the namespace and I'm done. There can be other variations of this also. So basically, this is the overall idea that my catalog of Kubernetes offerings needs to be diverse enough, accommodating enough, so that most of the people choose this way rather than that way. Because in an enterprise, you cannot stop anyone. The moment you are not diverse enough, somebody will find a way to do it. You cannot mandate anything. Somebody will find a way somehow. That is the reality. Another very important thing is this container or Kubernetes center of excellence. Okay, this is where we have seen that not many people they want to do it, but they have not maybe given the budget or the investment to do it, but you need this. Just like you need say, for example, a cloud center of excellence so that all of those cloud thought leadership comes from there. Similarly, you need a container or Kubernetes center of excellence. It's like a central team, okay, which you will make them directly responsible for managing your entire container-based workload. So here I'm just talking about Kubernetes, but it can be container apps. It can be, say, your monitoring logging using Prometheus, Grafana. It can be your networking using Kaizen. So many things are there basically that this team should take care of. So this team, in a sense, is basically your central team. You should reach out to this team. This team should manage, in a sense, the entire estate of all of the Kubernetes offerings across all of the service lines or all of the business modules. And this team should also include, basically this team will have 2 parts in a sense. It will have a support part, which is basically your 24/7 or whatever the support module you have, so that all of these Kubernetes clusters are getting monitored. Any problem is being resolved quickly. So there is a support team who can take care of the entire Kubernetes estate, but it should also have an architecture module, kind of like good Kubernetes or good architects, basically IT architects or cloud architects or solution architects who are sitting there with a deep expertise in container-based workloads, stateless applications, distributed computing, who can give you overall guidance, basically, on whether what you are doing is correct or not. So basically, there are 2 nuances to this. If you just have the support part, it will just become another support function. So you also need this kind of thought leadership or architecture part, which is sitting in this center of excellence. What are some of the functions of the central excellence team? Basically, that team is supposed, or the members of that team is supposed to maintain the set of best practices, set of best architecture guidelines, set of, for example, central processes, which every other service line or team should follow. Another purpose is also to evangelize. They are also, for example, like advocates of Kubernetes across the enterprise. Right. So they will maybe conduct roadshows, awareness sessions, ask people, promote Kubernetes, help people in adopting Kubernetes. They might manage a Kubernetes academy of sorts where they can, for example, help people with labs, hands-on, maybe conduct hackathons on Kubernetes. So some of those aspects this team will also do. Another thing that is very important is they should provide developer guidance, not only infrastructure or Kubernetes level guidance, because having the cluster, managing the cluster, monitoring the cluster, upgrading the cluster is one part of the story. Unless and until you have your application workloads deployed on the cluster, nothing is just another skeleton, right? So providing the developer guidance, ensuring that the developer experience is perfect. They should suggest IDs, tools, on how best to troubleshoot clusters, basically. How to deploy to clusters. Should I use Helm chart? Should I use some other? Should I use Argo CD? So all of those best practices should come from them, even on the development part of the cluster. Monitoring and managing all of these clusters centrally and ensuring that cross-cutting concerns are managed at a central level. This is also their duty. Conducting architecture reviews of container-based designs, providing recommendations, ensuring that all of the deployments are aligned with the enterprise-wide standards, identifying, recording, and mitigating exceptions. So basically, this is a standard center of excellence kind of thing, but more dedicated for Kubernetes. This is of paramount importance. To be very fair, without this team, it's very difficult to get forward because nobody will be able to take ownership of anything. You need somebody, some very strong people in this team who can kind of guide the enterprise into the direction that the leadership wants to move to, basically. Similar kind of like an offshoot of this is managing the document repository for Kubernetes consumption. So this center of excellence should publish basically extensive documentation on how to consume the enterprise Kubernetes offering, how to get started, all of the architecture best practice, everything should be in some place so that everybody can. One very important thing here is to also focus on the developer experience. So not only have articles, which we have seen many times, is that most of the articles are focused on the infrastructure or the DevOps part in a sense. But we also need to focus on the developer part. For example, how do I troubleshoot if my service is not getting exposed perfectly? How can I connect from my laptop to a cluster? How can I do some sort of port forwarding? What are some of the good IDs that I can use, like LANs, whatever, basically. So all of those developer-focused guidelines and tooling, custom tooling, maybe custom extensions for ADO pipelines, anything should be published here. Managing cross-cutting concerns centrally. So as you can understand, if it's a central team, some of the cross-cutting concerns should be managed by this team rather than by every single service line team. So the service line teams or the business teams or the portfolio teams will still have accountability, obviously, but the management can be kind of delegated to these central teams. So what are some of these things that they can manage? For example, log aggregation, distributed tracing, maybe maintaining the Nginx ingress controller, maybe the version of the ingress controller, certifying it, ensuring that any new vulnerability or CVE is being updated. So basically all of the central components that do not change a lot between projects, between portfolios, will be something that this central team will want. Say, for example, backup using some sort of a service like Velero or Veeam or whatever, disaster recovery, some of the security controls that you want, ensuring that all the container images are signed, maybe maintaining a kind of like an iron bank of container image repositories, all of those things, this cross-cutting concerns, this team is supposed to handle. Finally, establishing a consistent support model. Having a 24/7 kind of a support model is also very important. This part is basically a part of this overall bigger team, okay? But this support team, in a sense, is responsible for ensuring that the platform is up and running. So that is what I'm trying to say. So here there is an essence of an enterprise involvement in your workloads. It's not that you as a team is just spin up a Kubernetes cluster and you do your own. No, as an enterprise, we need to ensure that all of these Kubernetes, say for example, clusters are being controlled somehow. So there needs to be a control or management plane, which needs to be monitored. Say, for example, you have Grafana dashboards, okay, for all of your clusters, so that at any point of time, you can see, okay, this cluster belonging to this service line team has this problem. Okay, you might have an enterprise grade security tooling, like say, for example, Aquasec, which can, for example, check that, okay, there is this new vulnerability that has been released. So, okay, these are the 200 images which are running on all these 200 clusters that need to be upgraded to ensure that this vulnerability can be remediated. So this kind of a support model which supports the actual service line application teams, the developers, the DevOps engineers is very, very much needed. Automation to support containerized application development and deployment. So this is the second part of the picture that I was talking about. The first part is obviously having good automation, good orchestration capabilities to deploy your infrastructure, having a way to deploy a standardized Kubernetes cluster, right? That is the first part. But what is the next part? The next part is having an automation that can help you also deploy your application onto the cluster, right? So there should be some way, for example, that standard container images which are hardened should be available. There should be standard maybe CI/CD pipelines, extensible pipelines that any team can very easily maybe fork from the repository and just download and start using it. There could be, for example, an enterprise-wide image repository like JFrog, where you can keep all of your images. So all of this basically not only supporting the infrastructure part, but taking an end-to-end holistic view of the entire process. So infrastructure is done now. Okay, now what are the next steps? I need to build my code. I need to put my artifacts into an artifact repository. I need to deploy them. So this automation, these modules that the central team is developing, they should be in a fashion that any business team can just consume it without having to build it from scratch, basically. So the important thing here is that the differentiator is not the process by which you deploy. Most of the applications will deploy using the same CI/CD process. The differentiator is in the code. So the non-differentiating part, which is the same, for example, a standard pipeline which deploys a .NET code to a Docker, say a Helm chart, creates a Helm chart out of that, puts it into a JFrog repository, and then deploys it onto a Kubernetes cluster using, say, a service connection. So this part, this process can be kind of automated. It has been successfully automated in many enterprises, so it can be done. But this is something many people are not doing today. Many people still have their infrastructure as code to deploy a Kubernetes cluster in a standardized fashion, but that is where they stop. They don't look at that next part, which is the application of the developer experience. And the central governance and compliance. So this is where, for example, tools like Aquasec and all of them start coming in. So you need a way to ensure that, okay, your company has some secured images that only every developer can use. For example, having this kind of Aquasec kind of a, or some other, basically, there are many tools today, Kubescape, many other tools are doing Prisma Cloud, which are doing the same kind of thing, but it's an InfoSec and compliance mandate that you need to enforce centrally. You cannot expect every single service line team to know about all of this. They're relying on this central Kubernetes platform in a sense to take care of all of this undifferentiated lifting. Then the policies should be pushed to all Kubernetes clusters. Say, for example, there is a new policy that is a mandate for your enterprise. There should be a way that the policy engine, for example, you're using Kaiwan, for example, can push that to every single cluster so that every single cluster now starts enforcing or, for example, auditing the impact of that policy. But again, we also need to be flexible. All of these processes need to be flexible enough that wherever needed, customizations can even be done at the project or the product level. So say, for example, as a company, I am enforcing CIS benchmarks, say 10 security policies, but there is a product today within that enterprise which needs a HIPAA compliance, so it might need another 10 policies. So that can be put in kind of like a layered approach to security. So basically, this is what I was talking about when I'm saying that there are today challenges, but not all challenges need to be solved technologically. Obviously, we are expecting that there are good engineers, they have good architectures, scalable architectures, resilient architectures. They know how to code well, but this is not something that you can solve every single individually. This is something you need to do at scale. You need to remediate these challenges at scale. That is why you need to put in place processes, put in place teams who can have that holistic view of your entire end-to-end process, basically. And these are some of the strategies which are involving this kind of like an internal platform or IDP, internal development platform. And one part of that platform is this Kubernetes kind of an offering that you are pushing as part of that platform. And this is where, if you have this kind of a central Kubernetes offering and a team which manages that offering, then your adoption at scale doesn't have to be inorganic. It can be an organic growth. Okay, so this is a very important thing to understand. Say, for example, I have been able to do all of this. What is my Kubernetes adoption process? What is this new process, for example? So say your solution architect gets a business requirement from the business, okay? So a service line business team has given your solution architect a business requirement. Solution architect determines that the container or Kubernetes might be a good choice for the compute part of this, for hosting this workload. So what he will first do, he will go to the documentation that has been published by the Center of Excellence team, check all that documentation, validate his hypothesis. If he needs more inputs, he can request help from this architecture arm of the Center of Excellence team, where I said there are very seasoned, good architects, cloud architects, infrastructure security architects, very focused on Kubernetes workloads. So solution architect of the business team, business portfolio can consult this architect. Now, say, for example, the solution architect establishes that yes, Kubernetes is my preferred compute option. So he will work with his engineering team, maybe his DevOps team. So what will be the next step? You already have a self-service request process. So the solution architect or his teammate or whoever will basically put in a request to get a Kubernetes cluster via the self-service portal. Very simple. In the backend, an automation will run and it will create a Kubernetes cluster. So very easily, the solution architect is able to validate his hypothesis and build, say, for example, a POC environment on a fully functional Kubernetes cluster, fully functional, which is completely compliant with all of the enterprise security and compliance practices. This is very important. It's an InfoSec certified cluster. Once this is done, the Kubernetes infra is present. Now, what is the next step? Now the solution architect needs to connect to that cluster in a secure way and then deploy his application. Right. So now becomes the part of the infrastructure is done. This is the part of the application or the engineering part of the application. Again, the Center of Excellence team is publishing standard pipelines, standard modules, maybe ADO plugins, whatever, which can help a team to go very quickly from code to container to deployment. So the solution architect will use basically these automation building blocks which are available to package the application into some sort of a format, maybe a Helm chart, for example, put it in some sort of a container repository, like say, for example, JFrog, and then deploy them onto the Kubernetes cluster. This process of source to deployment has some accelerators that has been developed by the Center of Excellence team. As a result of this, what is happening? A fully functional app is now available, and it is deployed on a managed Kubernetes cluster. Nothing, you are not kind of deviating from any of the standards that the enterprise has put for you. So everything you have done as per the standards, but you have the flexibility. You are still able to deploy, and very quickly, to be very fair, you are able to deploy your application because there are so many accelerators available. Finally, you are verifying that, okay, my application is working. Now you can onboard your cluster, if it's a dev or prod or whatever, you can onboard it into the operational support team, which is also part of that COE team, but the support arm of that team. So that team will now take over the monitoring, the backup, the disaster recovery, all of that operational resilience part of that cluster and the container-based workloads that team will take over. So this is a much better position to be in than the other position where everybody was doing their own thing. So this is where we want to basically get to as the final step. Some of the tips and tricks that I understood when kind of, for example, doing this in some places where I had worked in. Number one is that structuring of this container excellence team is very important. So it has to have some sort of very good buy-in or collaboration with your, say, your architecture practice and your enterprise architecture practice. So most of the applications, enterprises will have an enterprise architecture practice. They will have a cloud solution architecture practice and many other practices. So enterprise are very different from startups in this way. They have this, they're very weird way of doing things, to speak, because they have to manage this at a scale. And this container center of excellence team will also have this support team. Now the product engineering team, so this is one business team, another business team, they will basically interact with these teams, maybe borrow resource. It can be different models can be evaluated basically. You can, for example, borrow an architect, maybe give them a charge code, they will work for you. There are many different ways you can do this. It's very standard approach, basically. It's nothing new. So this is very important. You have to structure your central excellence team in a very good manner and also ensure that proper people have been hired into that team. Another thing is very important. This is also that we faced. Try to make these offerings as cloud agnostic as possible. Say, for example, you're focusing only on Azure, okay? But say tomorrow there is a requirement that, okay, this application can only be deployed on AWS. So if you don't offer that offering within your platform service, then they will find a way to do it without it. And that is a much worse place to be in, right? Because business always will push somebody and they will get an exception and do it, okay? So always try to make your offering as accommodating as possible, or put in place very good processes so that people cannot get exceptions, whatever works for your enterprise. So this is very important. But is what I was saying is that this is also, we have seen that many of the teams, they start focusing on the cluster itself as if it is the most important thing, which it is. But even more important is the workload which is running on it and how the developer experience is around this. If the developer does not enjoy troubleshooting, deploying, and all of those things, if we cannot, for example, check and the log of a cluster very easily to identify, okay, where is my error? What happens? Say, for example, there is a divide by zero error. If I cannot identify it, then it's very difficult for a developer to work, right? So this developer experience is very important. So always think about this developer experience around your internal developer platform. That is the most important thing. And obviously, the last thing is you need high-level leadership buy-in. Otherwise, whatever I have spoken till now, nothing will materialize. It will just stay. Every team will do its own thing in its own way, and there is nothing you can do about it, to be very fair. And this is basically what I wanted to share today. And this is, I think, the end of the session. And I am completely okay to take questions, suggestions, comments, anything.
Cool. Thank you so much, Turja. That was a really fantastic presentation. And I already can see a lot of positive comments in the chat. So I think people really liked it. And we also have some interesting questions. So we are already running a bit over time, but I think it's okay to add another 15 minutes. And then questions we can't answer right now. I would propose that, Turja, you will be available in the platform engineering Slack space, and then folks can reach out to you there, and we can continue the conversation there. So I would love to start with the first question that Radha had. In our company, we are thinking to have different namespaces for different customers in a single cluster for every environment. Is this advisable, or should we go with one cluster per customer? We wanted to save costs by reducing the number of clusters. Is this something you have an opinion about?
Yes, I have an opinion. And again, this opinion is also like all the opinions we architects give is like it depends. But at the same time, see, very standard industry practices, for example, is basically the level of isolation you want. So even let's not even think about it as a cluster. What were you doing when you were deploying it maybe as a monolithic application on a VM? Similar kind of concept. Many people are today doing, for example, one cluster for prod, one cluster for non-prod, which is shared between dev QA as a namespace, and then another cluster for performance, because you want to do performance testing on a cluster which is kind of similar to your prod cluster to get the better results. But again, this all depends upon the level of confidence you also have on your own security controls. If you have, for example, very good granular level security controls, you can even host, say, for example, two different applications on the same cluster, meaning completely two different clients also. I mean, that is what multi-tenancy is about, right? That level of data isolation and logical separation that you are comfortable with. So obviously the easiest and the best secure environment would have been even, for example, one subscription per customer. That would have been even easier. Some people might go a step further and say, okay, one subscription per management group. I mean, there are so many things you can do to level of isolation. But again, at the same time, it's the same question of whether I should have different DynamoDB tables per client, or should I have, for example, one DynamoDB table and an index parameter with, say, client ID. So again, my recommendation would be at least to have one for prod, one for non-prod, which can be shared between dev QA, UAT, SIT, whatever you talk about it, and one for non-performance. In the performance cluster, we typically want to make it like spin it up, do your performance testing before every big release in a sense, and then again, shut it down if you can, or delete it if you have automation. So this is at a high level, my answer. But again, happy to talk more on this if you want. That's not a problem.
Okay, cool, thanks. Then Jacob is asking if there are some open source platform frameworks having the central Docker and app repository, basic CI/CD pipelines, automated deployment, and maybe even a self-service portal, or something built up on. Do you have any experience there or any recommendations you could give?
No, I mean, I don't know. Again, the answer also that Jeffrey gave is also good. But again, I don't know whether Rancher open source supports everything. I know, for example, for the Rancher has their enterprise solution also. So again, I mean, and I really don't know, I haven't heard about anything that gives automated CI/CD pipelines also. I mean, that is something also I have not seen. Maybe Rancher does that, I don't know. But yes, to be very fair, there are many, how to say, like they are calling themselves Kubernetes management platforms. Like say, for example, you log in and you see all of the clusters that you have access to. You can click on the cluster, you can see all of the pods, all of the services which are running there. You can directly, for example, restart a service, see all of their logs. So there are many applications kind of doing this. But what I was saying, to be very fair, is that they have not yet reached that level of maturity that, for example, SAP has reached in the ERP space. And that is okay, because the ERP space is much older than that. And that is where I am saying that there is a gap where we as the enterprise also need to contribute. We cannot just rely on the like by the build COTS, like commercial off the shelf software. I mean, it will not do everything for us, at least not for Kubernetes. Whereas for some of the other disciplines in IT, it is really good. I mean, there are some very good tools in some other disciplines of IT where you can just buy it and just rely on it. For example, if you want a CRM, you just buy Salesforce, for example, and you're okay with it. I mean, you really don't need to think about it. Whereas in Kubernetes, you really need to think about what some of these things you are doing. And that is where we as the enterprise also need a level of involvement in managing the processes, our best practices, because those things are still very, how to say, like fluid in this Kubernetes world.
Yeah. I mean, I guess many of us share this observation that there are not these one-size-fits-all tools that cover everything end to end. So yeah, building such a setup will be more like an own product you build out of different tools. The next question is, do you recommend having many clusters with granular resources, or is it more recommended to have a couple of really big ones and just deploying to namespaces?
Again, so say for example, this is completely based on the isolation philosophy of the organization as a whole. Say for example, there are many organizations I have worked with where they prefer one subscription, not even a cluster, one subscription per application. Okay, so that is where you are even going a step further. Okay, there are people who are even saying that my non-prod and prod subscription cannot be the same one. So if your non-prod and prod subscription cannot be a same one, how will you have a cluster? You cannot share a cluster across subscription, right? So again, that is what I'm coming back to, is basically the overall philosophy that you have for your multi-tenancy or your deployment. The same concept will apply here. If, for example, you are okay with deploying multiple applications on a single VM with tight controls, you should be okay. So Kubernetes offers that. Kubernetes you can put in place really good network policies, isolation controls, so that you can actually have a multi-tenant kind of a structure. Okay, it's not impossible with Kubernetes, but at the end of the day, it's completely up to the architect or the business team. Many customers will not be comfortable with having this, even though in a sense, when they're on AWS, they're having the similar kind of a setup, but that is something they cannot control. But the moment you tell them that, no, I want this, they will try to have some sort of a logical separation, ideally by a VNet or maybe by a resource group or by a subscription.
Okay, cool. Brett has another question on the Kubernetes team or the SRE team. You mentioned that manages and monitors all the Kubernetes installations and workloads as part of the support model. The question is, do you anticipate the focus on the workload applications or more the platform running the workloads, and supporting the diverse workload apps seems to be difficult for one team, as one comment that also focuses on the platform health as well.
Exactly. So see, this is very, I think, again, this all of these problems that we are trying to address with Kubernetes are not new problems, to be very fair, right? Whatever this Kubernetes team is doing, any central support team, for example, is doing in a similar way, very frankly. So for example, what many companies do is they have a minimum monitoring baseline. Okay, these are some of the standard alerts that you have to apply, as simple as that, on anything. So these are something that will normally route to your your central team, maybe an L1 support or L2 support, they will try to do as much as possible. They will have run books or playbooks, and then it will go. So mostly it is platform health. But again, this is not just a platform health. I mean, for example, it could be as simple as a service is down, or a pod is, say, crashing every 3 times. Okay, so three times every second, or something along those lines. Basically, what I'm trying to say is that those alerts will also come here. They might do some sort of basic level. Obviously, if your application is crashing, no support team, no central support team can do anything about it, no matter what. Central support team cannot do. Your individual project level SREs might still be different. So there is a lot of, I mean, it's not that simple, to be very fair, is what I'm trying to say, is that the central onboarding team will give you kind of some basic level, or say 50% of that level of things which normally break 90% of the time, and they will be able to monitor them. They will be able to fix them also. So these are not just like L1, L2. There should be some good level of expertise also in this team, that they can go in and do something. But at the same time, you also should have cluster admin privileges, right? So that if something is not working here, you also get that alert. You also get into that same call, on pager duty or whatever, and try to fix that. It can be a platform level problem. It can be, say, for example, your application is crashing, in which case no platform engineer will have that level of expertise that they will be able to go into your GitHub code and see, okay, this is the reason I had added this rule in C#. That is why I have to remove this rule. Very difficult for any support guy to do, to be very fair. So like you said, mostly the focus will be on this kind of common issues. Say, for example, some pod is breaking, some node pools are, for example, the backend Vim VM scale set is not scaling. Anything, any platform level problem, they should be able to address at a high level.
Okay, thank you so much. I think we can wrap it up. We are almost 60 minutes. So there was a fantastic presentation, Turja. Thank you so much. Thanks to the audience for joining. Thanks for the healthy debate and all the great questions we had at the end. And I would say, yeah, recommend, let's continue this discussion on the Platform Engineering Slack. So platformengineering.org, you find a link to our Slack space, and then we can continue there. Tomorrow, we will send out a follow-up email with a link to the recording and also a link to the great slides you've shown. And yeah, thank you again, and hope to see you all in one of the next meetups, and latest at PlatformCon 2023.